So there's this idea, the pigeonhole principle in machine learning, where you're trying to cram so much information in. At a certain point, something has to be popped out. Like, you're not going to be as good at these other things. Math models take that to an extreme and say, like, I'm just going to get really good at math. Maybe I'll be able to do the other things in just like a barely passable kind of way. If you know anybody that does, that has a math PhD, that might seem familiar. But anyway, hi, I'm Scott. I'm a PhD physicist and I've built an AI startup. And I'm here to give you insight into the extremely hype-filled world of AI.
Problem 1. Chen Gendron conjecture. An algebraic geometry problem involving differentials that require an strange formula from number theory. The AI found a connection to a 19th century numerical phenomenon and generated a complete proof. Problem 2. Fell's conjecture. It's a problem concerning syzygies. Axiom provers solved this entirely autonomously from start to finish, remarkably appealing to formulas from Srinivasa Ramanujan's work from 100 years ago. The dead ends problem, a probabilistic model in number theory, was proven alone by the axiom math algorithm.
How are the models different to solve math problems than to generate speech or generate text or interact with folks through text or speech? The math models don't have to be different, but like the general idea here is that it's a sequence-to-sequence model. You'll have a sequence input, you'll have a sequence output, and the general inner workings of that sequence can be big, expressive, etc., different things. Also, the model can be exposed to all sorts of things in the world. But the difference would mostly be the underlying training data that they're trained on. So it's less about the models and more about the training data that the models are trained on. It's kind of like a human. Humans, we all have brains, well, most of us, and we go to elementary school, we go to, college, some of us, we get real world experience out in the world, etc., that type of thing. But we all, drink water, we all eat food, we all learn the way that we learn, etc., that type of thing. But we're all experiencing different things. We grow up in different families, we grow up in different regions of the world. We grow up with different cultures. We have different training data given to us. And then in the end, we come out, yes, the DNA differences and that type of thing, but also a lot of it is from the cultural upbringing that we have. That is your training data. That's where the differences in humans come from. And so a math model will have a lot of that it's learning about, more so than the general models. Now, you could say the general models could also be given that math, yeah, but they have to balance a lot. They have to learn about random facts in Wikipedia, they have to learn about all sorts of things. And so there's this idea, the pigeonhole principle in machine learning, where you're trying to cram so much information in. At a certain point, something has to be popped out. Like, you're not going to be as good at these other things. So math models take that to an extreme and say, like, I'm just going to get really good at math. Maybe I'll be able to do the other things in just like a, barely passable kind of way, like a conversational kind of way. And you might, if you know anybody that does, that has a math PhD, that might seem familiar. But anyway, so these models are more focused, toward math, mostly from their, training data. But they could put a few little tricks in there, like allow it to use a calculator and, all sorts of things like that. But yeah, so this is how the models are different. Well, there are no PhD math jobs to begin with. We don't fund it in the US anymore. We stopped doing that in the 80s. This actually, I would back that this is a more stimulating event in the economy of proving things. One of the reasons that proving things is not valued all that much right now is because of the high cost and sort of quote unquote waste in doing it. You hire all these people. What are the new proofs that you get in a year? Not that many. How many are extremely valuable to the world? It's arguable that it might be only, few a year or something like that. So I bet that, giving these folks superpowers to go out and do these types of things is actually very stimulating to the mathematics economy. The people who like the act of proving, so like I like to write things down on paper and just go through it and whatever, they will be severely disrupted and unhappy. The people who like the result of proving something and then using it to go do something else, they're going to be extremely happy because things are going to move fast and furious now. And then I bet they'll be able to get a lot more funding to do it. But I've used this example over and over before, but you may really love to work your shovel and be a shovel operator, or, you work your axe and cut down trees or whatever. But guess what? There's backhoes now and you need to learn how to operate it. And there's, chainsaws and you need to learn how to operate it. And it's a different world. Learn to love your saw, learn to love your backhoe, or it's just a hobby for you, basically. You can still go out and chop a tree with an axe. It'll just take way longer. You can still go out and dig a hole with a shovel. It'll just take way longer. And you can do it for the love of the art of digging a hole. But the game is going to change drastically now. Are they going to be able to push the frontier? Sure, maybe they get really good at this, at a more bounded, finding solutions to more bounded problems, or solving them in a more bounded way. You direct them to go do the work. This is akin to like a junior employee at a company, or maybe an intern or something like that, where, hey, it's a smart person, sure, but they don't know too much about the environment that they're in. So then you give them the context and you tell them, do this thing, I'm going to check up on you to do that thing. And then, yeah, it provides value, but it's not the open-ended value. It's not the full AI company being run type of value. But hey, will these math models or solution techniques get to that point? I have no doubt they will. I would say that they already do. And a lot of what happens in these frontier models, if you just take some constraints now and give them to a frontier model, they will come up with novel things and suggest them to you. And if you're an expert in that field, many of these things you will be like, ooh, that was better than what I thought of. Or I never would have thought of that. Or there's a list of 10 things here. 3 of them are bogus and stupid and we shouldn't do them. 7 makes sense. These 3 are extremely good. So it's already coming up with creative things that it would take a human just way too many processing cycles to go down. You only have so much time in the day. You can only think about so many different things. You can only notice so many patterns. And these models are not experiencing just your life. They're experiencing everybody's life. Everybody's using them at the same time, etc., giving them new ideas. It learns way slower than humans and everything, but it's learning in this sort of widespread way. And so, you have this shared knowledge being compactified into these models that you can interact with, and they're already coming up with new ideas. So I think if you couple some new idea generation with some scoring of those ideas and, just have humans help with that for now, but then build models in order to help with that later. Then you couple that with the more grunt work, go prove it or do this or whatever. And then you put those systems together, then, it'll be 2 years from now and these things will be generated like crazy. And you know what? I've seen this. So years ago, I was a particle physicist working in particle physics. And there are teams of people sitting in rooms working on their laptops generating histograms. Yes, all of particle physics 10, 15 years ago, up to 30 years ago or more, was just sitting at your laptop and generating histograms. So just generating bar charts, okay? And then you would think it's a super sophisticated thing that's happening. For the most part, you're just generating histograms. That's it. But the histograms will tell you something if this bar is bigger than that one, that means something. If there's a shake here, well, that means something. But in the last 10 years, since end-to-end deep learning has come around, and been proven to work at large scale, then the naysayers that were I'm just going to build my histograms, I'm going to use that in order to figure out if there are new particles or whatever. They're all changing their tune very drastically. Now, I can tell you 15 years ago, there are a lot of naysayers in physics saying, hey, AI has already been tried before. It was tried in the 80s. It was tried in the 90s. None of it worked. It's not going to work now either. Well, they were wrong. And all of that has now been disrupted drastically. Yes, there's still the histograms generated. There's still people doing it the old way in some ways. but they're using these other techniques in order to get way more leverage. You don't have to have 1,000 people to discover a formula anymore. It might be 100, a smaller number of people, but to make the same amount of scientific progress. So yeah, is that going to happen in math? Yes. Is it going to happen everywhere? Yes. Are you going to generate new drugs with this? Yes. Are you going to do new chemistry with it? Yes. Are you going to hook them up to robots to then do the chemistry for you, or like drop things into things? Absolutely. And the people who aren't excited about that right now, that work in those fields, sorry, you're going to be the dinosaurs. Science progresses one funeral at a time. So like your graduate students, your undergrads, your postdocs that are with it, they're going to get excited about all of this. They're going to push the frontier forward. Same thing with math. Hey, but that's just my take. Maybe there's something there that I'm not getting right. Please tell me down below in the comments. Hey, if you want to stay ahead of the AI curve, you might want to subscribe.